Switch this here. All right. Good morning, everyone. That's a kind of a strange thing to say, actually, because usually we are saying good evening or, yeah, because we have our Friday night live streams and our observing live streams, which usually we call Night Sky Live because we're observing at night, the planets, the stars, you name it. But today we're focused on the annular solar eclipse that's happening across the states. And in some places, it's a partial eclipse. Others, you have the path of annular eclipse. And we've got actually a nice surprise for you because even though across the Northeast, which is where we're based, we're in Vestal, New York, uh, it's overcast and it's rainy almost no matter where you are. Um, we happen upon a way to observe this eclipse event. One of our science educators, Sasha Zalesski, is actually down at McKinney, Texas, with her gear, and that is the window you see just above me. So we'll meet Sasha in just a few minutes. Before we do, I just want to show, for anyone new to the Kopernik Observatory YouTube channel, I just want to mention who we are quick and where you can find out more about us and how to continue to interact with us. So we're Kopernik Observatory and Science Center. We're located in Vestal, New York. And that's just in the southern tier of New York State. And this is our website, kopernik.org. If you ever want to learn more about Kopernik, this is a great place to go. You can find our events here if you're ever in the area. You can, of course, attend our in-person programs. We just had a wonderful presentation, actually two presenters. Dr. Saladino from the Space Science Institute yesterday gave a talk on eclipses and transit events and how they use transits to discover exoplanets. And then our Director of Education and NASA Eclipse Ambassador, Dr. Susan Higley, gave a presentation on how to prep for these eclipses, not just this one today, but also the one coming in 2024, which is even more exciting because it's a total eclipse. So that was a great presentation that you can also go back. That's posted to our channel now and chaptered out, so you can skip around and watch the different pieces of content there. I'm realizing my mic might be a little bit high, so I'm going to drag that back here. Hopefully that's a little better for you. And yeah, we have a variety of observing live streams that we cover. We're going to have an Orion and meteor shower stream next week. And you can find out more about our public programs just by going to this tab, going to upcoming events. Okay, there's a whole list for the fall. We are going to have Dr. Golish, an imaging scientist from the University of Arizona, come on our channel and here as an in-person event to talk about this program, To Bennu and Back, which is OSIRIS-REx that delivered the sample back to Earth. So that'll be a nice one. I do want to lastly show you our clear sky chart at the very bottom of the page. If you click here, the clear sky chart is a forecast model more specific to more specific to our astronomical viewing. So you have cloud cover, transparency, seeing, darkness, and really what you want is blue across the board. This is why we're really not going to have much chance to see this eclipse. Although, hint, hint, you might be seeing some eclipse just above me here happening in McKinney there. So let's go back here. You can use that to determine whether we'll be open on a Friday night, for example. Best time to visit us on site is a Friday night. Right now, this time of year, we open at 8 p.m. All right, and with that said, I'm going to bring on our, we have two Eclipse ambassadors here that are helping us at Kopernik. Sasha Zalesski is not only an Eclipse ambassador, but also one of the educators here at Kopernik Observatory. And as I said, she is down in McKinney, Texas, with her gear doing a remote stream that we're seeing in the window above me now. And I'm going to switch to the next scene, and Sasha's going to give us a presentation on how to observe this eclipse event safely and what eclipse events are. So, hi there, Sasha.
Oh, hello everyone. So thank you for that introduction. As Jeremy mentioned, I'm Sasha Zalesski. I'm an Eclipse ambassador and also an educator at the Kopernik Observatory and Science Center. Now, one of our main jobs as Eclipse ambassadors is to help people understand how to observe solar eclipses safely. So, right now, I do have our live view of the eclipse, which just started. And I'll kind of discuss a little bit about the different types of eclipses because the way we view them is actually a bit different. Also, if anyone is interested in becoming an Eclipse ambassador, if you are an undergrad student or amateur astronomer, we are still looking for more people. That especially we have a lot of partners that are looking for someone else to work with for the program. So definitely check out the Eclipse Ambassador website if that's something you might be interested in, especially to help prepare the communities for the April total eclipse. So, without further ado, our first type of eclipse is actually that total eclipse. So today we're observing an annular, but as you can see here from the diagram, there are two parts to the shadow. I'm trying to find my cursor here. Two different parts to our shadow. So there's the penumbra, which is if you are located in the penumbra, which we will be for the annular eclipse, you will get a partial. And if you're located in the umbra, you will be able to see a total eclipse. So, what exactly is a total eclipse? That is when the moon completely covers the sun. And actually, if you are observing a total eclipse and you are in the path of totality, right when the eclipse goes completely covered, you can actually take off your eclipse glasses if you have them and view the sun. Well, not the sun, but the eclipse with your naked eye. Don't observe the sun with your naked eye. And in case anyone is curious, we can actually see what that looks like from space. So, that dark part of the shadow, that is the umbra. So, anyone located in that region would be experiencing a total eclipse. And anyone in kind of that lighter gray region would see a partial. Now, what would the opposite of this be? If the moon was on the other side of the earth, whoops, we would be able to see a lunar eclipse. So again, the shadows are the same. We have the umbra and the penumbra. And actually, for a lunar eclipse, when the moon goes into the penumbra, it's a little bit hard to see. It's just almost dimming. I actually do have a couple images of that. And when the moon goes into the umbra, then you actually see it darken across. So I'll show you an example of that. So right here in this top corner, you actually do see the moon going into the penumbral phase, and it just looks dim slightly. But when it goes into the total eclipse, it becomes red. So this is actually caused by something called Rayleigh scattering, where the blue light gets scattered by the Earth's atmosphere as the Earth blocks the sun, and that red light is the only thing that ends up hitting the moon, which causes it to look red, which is called the blood moon. Now, what makes the eclipse we're seeing today different than a total eclipse, which I talked about earlier? So, actually, this has to do with the distance of the moon from the Earth. So, the moon has an elliptical orbit. So, there are parts where it is closer to the Earth and further. If you've heard of the supermoon, that's when it's closer to the Earth. And when we're observing annular eclipse, the moon is a bit further. So it actually doesn't quite cover the sun completely, and we get that ring of fire. So we are introduced to a third part of the shadow called an antumbra. And anyone in that antumbra will see an annular eclipse. So we see that umbra actually narrows and just kind of gets cut off completely, and what we end up seeing is the antumbra. But if you are located in the penumbra again, you see a partial. So actually here at my current location, McKinney, Texas, we will be seeing a partial eclipse. And I'll also have some maps and diagrams to kind of show exactly what we're looking at here and what the path of totality does look like. Actually, the path of annularity for annular eclipses. So all of those diagrams I showed earlier, none of them are actually to scale. If you do want to see what the distance from the Earth and Moon look like, it's actually right here. So this is a 2-scale image, and you can see how far the moon actually is from the Earth, as well as their sizes. So for a lunar eclipse, a lot of people say they tend to occur more often, which actually isn't true. Solar eclipses and lunar eclipses occur at the same frequency. So why is it more likely? Why are you more likely to actually see a lunar eclipse? So for those solar eclipses, you have to be in a very specific point. You might have noticed that earlier on those diagrams. And when you go look at the actual path of annularity and totality, you'll see it's a very small area. So you have to be located in that specific area to actually see the eclipse. But for a lunar eclipse, if it's nighttime and there's a lunar eclipse occurring, you'll actually be able to see it. So Earth's shadow is so big in comparison to, say, the moon and the sun, that you'll actually be able to see a lunar eclipse simply if it's nighttime and there's one occurring at that moment. It's also interesting to note, actually, in my next slide, I will talk about that. So the reason, if you might have noticed, during solar eclipses, the moon is always in a new moon phase. And during a lunar eclipse, it's always in a full moon phase, as it has to be opposite from the sun to actually be in that full moon phase. So by that logic, why don't we have a solar or a lunar eclipse every month? It actually has to do with the moon's orbit. It's on a 5-degree tilt, so it's not aligning perfectly every time it orbits the Earth. Only twice a year do we get that perfect alignment needed for an eclipse. And either 2 weeks before or after a solar eclipse, there's going to be a lunar eclipse. So there's actually a lunar eclipse 2 weeks after this, but it's a partial. There won't be a total lunar eclipse until 2025. To kind of also demonstrate the frequency of solar eclipses, this is a map for about less than the next 20 years, which shows all of the eclipses we'll be able to see. So this red one right here is actually our annular that we are observing today. And in April, we'll get that total eclipse right across the East Coast. I know you guys got some rain over there. Right now it's thankfully sunny, but it is a bit windy. So hopefully we're going to have good weather in New York for that eclipse, because only 1 hour above Binghamton we'll actually be able to see totality. Although here, I have another map a bit later, which I will show. But there is one other interesting eclipse I wanted to mention here on this map. It might be a little hard to see because it's this very thin line. But in 2031, in November, I believe it's November 14th, there will be something called a hybrid eclipse. So these ones are they're quite rare and a little difficult to explain. It has to do with your position relative to the moon on the Earth. And depending where you are, you will either see an annular or a total eclipse, which is why they're called hybrid eclipses, because you get to see both, depending where you are, of course. So that's another eclipse I wanted to mention there. Now, another thing you might notice on this chart is that the lines have varying widths, especially towards the poles. They're really big paths that we can actually see. So what causes that? It actually has to do with the curvature of the Earth. So towards the poles, you can see here, the light is more spread out and it is less direct than, say, if you're near the equator or the tropics. Then you get more direct sunlight and therefore a thinner path. But if you're near the poles, you get to see a much larger path. Now, another reason, I forgot to mention this, but when we're observing solar eclipses, another reason why we don't see them that often is that our Earth is mostly water. So we actually don't get to see any eclipses if they're occurring over water, unless you take a boat, which I know some people do that. So if we come over here, we actually get to see our 4 types of eclipses. We have our partial eclipse, which we will be observing today. It will be a little bit more covered. I believe McKinney will get 88%. This is what an annular would look like. So especially if you're in the Texas area, San Antonio or Odessa are kind of right in that eclipse path. So they'll actually be able to get to see that ring of fire. Now, in a total eclipse, right at this part is actually when you would be able to take off your glasses to view totality. Otherwise, you wouldn't be able to see it if you didn't take your glasses off. But total eclipses offer us a really unique view of actually the sun's atmosphere. So this effect is called, the solar corona. So that would be something we would be able to observe in a total eclipse. And then, of course, we have our lunar eclipse here. Now, if we look over at Texas, we will be able to see that path of annularity. So like I mentioned before, my cursor is gone again, but we are able to see that eclipse path going over Odessa and San Antonio. And I am located in McKinney, which is right next to Dallas, right here. So we're not quite in the path of annularity, so we won't get that ring of fire, but we will get a really nice partial eclipse. Now, if we were able to see the New York eclipse, you guys would get about almost closer to 30% in coverage from the sun. I don't have a map for the total eclipse, but if you guys are interested in finding that, it's really easy to find online. And also, Time and Date is a great website to also look up what percentage of coverage you may have in your particular location. Now that we know a little bit about how solar eclipses work, how can we safely observe them? So, and why do we want to safely observe them? The answer to that question is pretty simple. We don't want to burn out our retinas. So actually, even if you're looking at the sun and that's comfortable, you won't know that your retinas are getting burned out because there's no pain receptors there. So ideally, we want to protect our eyes as much as possible because we don't want to have any kind of permanent damage. So one way, of course, is solar eclipse glasses. So many of you guys have probably heard of these. I just do want to warn you, don't get them off of Amazon. There is a standard. So actually on the temple tab of your glasses right here, you will be able to see a little thing that says ISO, and it will tell you if it meets the requirement for that certification. The problem is, however, people can get that little logo off the internet very easily. So just be careful with buying your Eclipse glasses. Definitely look for reputable vendors, and I can actually show you where you can find them in order to buy your Eclipse glasses. So NASA actually did compile a list of reputable vendors. So if you follow that link, I know you guys can't click it, but if you want to copy it down, or you can just look up NASA Eclipse Safety. This is a screenshot right off their website. So you're able to find that, and that's what it will look like. And right in that first paragraph, there's a clickable link in order to find that list of vendors. So don't buy them off of Amazon or some other sketchy looking site. You definitely don't want to play around with your eyes. Now, if you don't have eclipse glasses, don't fret. There's other ways to actually observe an eclipse without having glasses, and they're pretty simple. So one would simply be creating a pinhole. So when you create this pinhole, any kind of small hole, if you have a hole punch, that will work just fine. And you can actually create projection on the ground, or if you want to put a piece of paper under it, of what that looks like. Now you can create more fancy ones, such as pinhole projectors. This isn't the only design you can make. You can definitely find tutorials for this online. A lot of Eclipse ambassadors, see if there's one in your area. They might be holding workshops to create something like this as well. So definitely take a look online if you're interested in creating your own pinhole projector, because that can certainly be a safe way to observe a solar eclipse. Now, if what we need is just a hole, do we have to make one in paper, or can we just use something that already has holes in it? And the answer would be yes. I really like this picture. It's just a colander, and I'm not sure if you guys can make out the little crescent shapes in every single hole there. But that is another way that we can safely observe it. And here's a few other examples and ideas. You can get creative with it, certainly. It's a little difficult to see, but this is actually a hat. And someone used the little holes from the hat. They also don't need to be round. I heard someone said they used square holes one time, and that seemed to work fine. There's a little spoon. And another thing you can actually do is just cross your hands over like so. And if you just hold them down, you'll be able to kind of see that crescent shape in there. So you might be able to make it out in this picture as well. Now, another interesting thing we can observe with shadows is also looking at shadows of trees. So there will be little spaces between the leaves, and that will actually project that crescent shape where the shadow is. So that's another unique feature we can observe. All right. Now, just to conclude, if anyone has any questions that they would like to ask, you are free to throw them over in the chat and we'll definitely answer them. So if anyone has any questions, I'm going to just read through real quick. All right. Jeremy, do we have any questions that I may have missed?
Let's take a quick scroll here. Let's see. Not as of yet, but yeah, if you do have a question about the solar eclipse event today or solar eclipses in general, feel free to put them in the chat at this point. We are entering into a discussion section so that we can just focus on the eclipse in the large window now. And actually, let me see if we might be getting cut off a little bit, Sasha, on the eclipse
I'm
view.
going to adjust that in one
Okay.
second.
Yep. And then we'll see if there's any questions that pop out after.
All right, sounds good.
So in our eclipse view as well, the partial eclipse is now well underway, as you can see. But we do have a couple of sunspots. There is certainly a large one coming clear into view. Before I saw another one, but now I'm not seeing it as well.
I might need to adjust the exposure here.
Oh, okay.
As the moon comes up, yeah.
Oh, now I'm kind of as it moves, it's popping out a little bit better. But yeah, there are at least two sunspots that you can see up towards the upper part of the image of the sun, heading towards the center.
All right, that should be pretty centered now.
All right. Yep, that looks good. Perfect. We did have a question come in, and I'm prepping some because I had to look this up. Actually, I knew there was a partial eclipse, partial lunar eclipse coming up at the end of this month. It's not something that will be visible.
8th, correct?
Yes. Yep.
Yeah.
And it's not something that will be visible for our area, but this person is asking from. Let me go back to this chat here. Yeah, their specific question is, what will we be able to see of the corresponding lunar eclipse in the UK? So I see on timeanddate.com, as you mentioned in your presentation, a great place to go to learn more about eclipse events and the specific times. This partial eclipse starts in, I have it set up in London. 7:01 p.m. the penumbral eclipse begins. You get maximum eclipse at 9:14 p.m., which unfortunately for this eclipse, there will be some penumbral shadowing that you'll see, but with the umbral shadow, you just get a tiny sliver on the 28th. So that will show up, though. You'll get a tiny bit of red moon there at 9:14 on October 28th. Not visible for us in the States, though. Let's see, is there another question here? Oh, this is one. Yeah, I don't know off the top of my head, and I'll ask you, Sasha, in case maybe you know. They ask, when was the first solar eclipse documented? Do you happen to know when this first solar eclipse was,
Um,
or when it was documented?
that's not what I meant. I was trying to get over to the stream and an ad started playing.
Oh no.
So actually, I did a little bit of research, and it looks like the first documented solar eclipses have definitely been occurring before
Mhm.
humans, but it looks like the first historical dating on a tablet was in the March of 1223 BC.
1223 BC. All right. Well, there you go. That's
And obviously, back then, eclipses were probably a bit of a sign of doom to a lot of people, since they didn't exactly understand what was going on at that time.
yeah. I imagine it was pretty scary for early humans.
Yeah, for sure. Yeah, because during especially total eclipses, it does get dark, almost like nighttime, and you're able to see stars, as I'm told. I haven't experienced a total solar eclipse myself yet, and this is also my first annular eclipse and partial eclipse. So,
Yeah, it's great that we have these back to back eclipse events happening. Let's see. So,
it's going off view again.
oh, it is. Yep.
Mm-hmm.
This question actually from Andrew Zalesski.
Oh.
Why is the sun white in this view and not yellow?
All right. Well, that's my brother. So, hi, Andrew. So the reason why is actually I'm using a monochrome camera right now, and also the filter. It's very similar to kind of the filter you would use on your Eclipse glasses. I can't show it right at the moment, but yeah, the camera is monochrome. And actually, the colors of the filters you use can affect the colors of the sun. So, our AP 6-inch telescope that we have at the observatory has a green filter, so the sun actually appears green. So, all of that would depend on, well, the camera you're using, what filter you're using, and that's why the sun would be white and not yellow.
Perfect. Thank you. Patrick Manley here. Well, actually, for those in the chat, Patrick Manley is from the Kopernik Astronomical Society, as well as Sasha and myself. That's our astronomy club here at Kopernik Observatory. And he's just saying, so glad you went to Texas, Sasha. And it is pouring rain here. It is indeed.
Yeah, as I've heard. Thankfully, I only see that is actually, I thought I saw a cloud, but it's actually birds. So, yay. So, no clouds at all. Clear
Yeah,
skies, but it is a little windy.
it sounds like a beautiful day there. It looks the nice blue sky behind you. It's perfect. The exact opposite.
Mm-hmm. Ooh, someone asked about, oh, someone asked if they have a filter for their smartphone and they hope it doesn't burn out their camera. So a lot of people will get filters for their smartphones and they should be fine to use on your cameras. However, do not look through them with your naked eye. So they're not designed to be looked through with just your eye, but it should be fine with your phone camera. The only difference would be is you have to figure out how to photograph it without also looking at the sun at the same time, because you don't want to damage your eyes. But if your filter is not one of those, again, from the more like suspicious sites, you should be fine. I know a couple, there should actually be on that list that I mentioned earlier on that NASA website, they'll have some other reputable shops to get filters for cameras as well.
And just to add on to that, depending on the lens stack inside your smartphone, you do have to be a little bit wary of doing anything without a filter. Certainly, like, you can take a picture of the sun with your. I mean, you probably have in the past. Take a nice sunset, anything like that. But the trick there is you really ideally don't want it fixed on the sun constantly, because that's where you're going to build up a lot of energy in that lens stack, and you may or may not damage it. So just please be aware of that when you're imaging the sun during this event. It is tempting to just hold a camera up. And as Sasha said, you don't want to be looking at the sun yourself at any point during that imaging.
Another thing that might be important to note is a lot of people think they can just use sunglasses since they're meant for wearing when there's a lot of sun outside, but don't use them to look at the sun. So even though they do dim it just a little bit, it is still not safe. And again, you don't feel that your eyesight is actually being damaged. I did have a classmate, and I actually did ask if I could share her story, but as a kid, she mentioned that she looked at a solar eclipse with just her naked eye, and when she looked down, it was only for a couple of seconds. She noticed that her vision was slightly blurry, and she actually now says that before she had 20/20 vision, everything was great, but after that solar eclipse and after she looked at it with just her naked eye, her eyesight just progressively gets worse and worse every year. So we definitely don't want to damage our eyes. So that's a really important thing that I'm going to keep mentioning during this eclipse today. So definitely do take measures to protect your eyes when viewing the solar eclipse today, and also in April coming up.
That really is a telling example of the long-term damage that it can do. You may not even notice it straight away.
Exactly.
Oh, I also meant to mention on the filter topic, when you're imaging with your phone, if you do just have your solar glasses too, I mean, maybe you mentioned that, Sasha, but you could just use those as well. But again, make sure you frame it up right. Even using the front-facing camera, that'd be a great way to try and frame things up.
Yeah, and some other things about solar glasses as well. A little common question we get is if you can only use them once. And actually, you should be able to use them over and over again as long as the lens doesn't get damaged. So if the lens gets scratched, punctured, torn, anything like that, if it starts coming out of the frame, please discard those glasses. They are not safe to be viewed through. But if you keep them in an envelope, I hear a lot of people recommend just keeping them in an envelope. They should be fine to be reused as long as nothing actually happens to the lenses. And careful with accidentally touching the lenses too, because I accidentally did that on one of my extra pairs. And unfortunately, your fingerprints do definitely get on these, and it's hard to clean off without actually potentially damaging that lens. So do be careful to also hold them by the frame if you do have a pair of Eclipse glasses.
Oops. That is a great tip. Yeah. So especially with the next solar eclipse coming up, if you have a pair now and you want to keep it around till the 2024 one, yeah, that's critical. So this is about, I think, just about where we are in the eclipse, this stage of the eclipse, where ours would be at maximum. We're heading towards this 20% mark for our area. That's about what we would see in New York if we could peer through these clouds. But this is going to keep going, right, Sasha?
Yep. Should keep going up to 88%. All right. Someone's asking a question. They sent me a message. They're asking when the next solar eclipse will happen and who will be able to see it. So the next total eclipse over the United States will actually be on April 8th, and mostly the East Coast. So I did have that map up earlier, and it will kind of travel down from New York in a curve all the way to Texas. And actually, what's funny is McKinney will be in the path of totality, almost right in the center there. And someone else asked a question in the chat, and I hope maybe I can touch on it. If you're in the path of totality or annularity, the closer you are to the actual center, you'll be able to observe that the annularity or the totality for a longer period of time. And also for annular eclipses, how centered it will be as well.
Yeah, I know, like for us, if you travel just to Syracuse, you'll have maybe a couple minutes of totality, but get closer to that center line and things improve a lot. So it seems like it's going to be worth any trip further north for us here in New York.
Someone asked, do you think we'll be able to see the entire ring for a few minutes, even though it's only supposed to be a 90-ish% eclipse? So unfortunately, in the region we are right now, we won't be able to see the ring. So we would have to be in the path of annularity to actually see that ring. So what we'll get is a crescent shape for this eclipse. So we are viewing a partial eclipse today.
And what's kind of neat too, this is at a lot more convenient time here in the late morning and then into the afternoon. But this eclipse we're going to see from the perspective in Texas isn't too far off from what we got back in June of 2021. And that's actually something you could even go and compare right now to our footage from that event. There it was almost 80% eclipse in New York. We could see that one, but it was early morning. It started something like 5 o'clock in the morning and then ended around 6:30 a.m. and had already started by the time as the sun was rising. So kind of a neat one there too, and something you could go back and compare to in our videos. Oh yes, someone's mentioning the behind me here. We do have the Hubble of, and good eye too, that you notice this is the Hubble of the Pillars of Creation right there. It's very cropped, but and oh yes, I do want to mention we have another Kopernik Astronomical Society member that's joined us in the chat, Joe Bergeron. And I would like to thank him for providing a lot of our equipment that Sasha's using down in Texas. Actually, in case anyone's curious, I do have the full list here. Let me bring it up. I think I do. Yeah. And by the way, whenever we mention equipment that we're using during our live streams, it's not necessarily a direct recommendation for what might be best for you to use. It's just what we have going at the time, what we have available. We have a whole slew of equipment at Kopernik that we pull from. And we got to be also careful and mindful that we are also an on-site, in-person public observatory. So we can't for example, today I probably wouldn't have been streaming on one of our dome telescopes because those would be used for visual observing. So yeah, just keep that in mind. We use a variety of equipment here, and this is just an example of that. So what Sasha's using in Texas, we have a refractor telescope. It's a 16 millimeter doublet APO refractor. And that's a focal length of 370 millimeters if you're in tune with telescope optics. And then the tracking mount, that's an Ioptron, right, Sasha? Ioptron Sky Guider.
Yep.
Okay. And then the camera we're using is a larger frame ASI camera. ASI 183 mm. And that's what's capturing our view of the eclipse that you're seeing now in the big window. So again, thank you, Joe, for providing that equipment. It would not have been possible without your assistance there. This is a curious question. I'm trying to, maybe I'm misinterpreting it a little bit, but I'll read it out loud and maybe it'll make more sense to me or you, Sasha. It says, is the sun considered non-binary when it's at full eclipse? It's at full eclipse. It's like the way I'm reading that is binary stars, right? So the sun is a non-binary star system as far as we know, and there's nothing really to say that it is a binary star system. There's some that theorize that there's a planet that we haven't discovered yet, perhaps. Like there's a little bit of gravitational error there that could posit there's another planet. But beyond that, the sun is a single star system, which is quite rare in the universe. Most star systems out there are binaries, or even more stars than that, triplets or quadruplets. I'm sorry if I misinterpreted that in any way, but that we have what type of telescope is best to observe an eclipse, a Newtonian reflector or a refractor? Yeah, I don't know if I have a specific taste on which one would be best. It really is a matter of just capturing the field that you want. We chose a wider field for our setup here, just so it would allow us some wiggle room on tracking. But of course, you could push magnification if you had really strong tracking and could stay on top of it. Like one of our dome telescopes would do a great, and actually any of them would do a great job at that. So that you got to think about how narrow you want your field of view to be, for one thing. And our just by happenstance, I mean, our solar telescopes here, they are primarily refractors. Our heliostat that we use for solar projection is a refractor, and the 6-inch telescope in the dome that we use for solar observing frequently is a refractor. The sun's also such a close and large and bright object that you really don't need a ton of power. And in some cases, I'd imagine it might be a little dangerous to have, especially you wouldn't want to aim a large reflector telescope without any sort of filter at the sun. That's not going to end well.
Yeah, definitely don't observe the sun with a telescope or binoculars that don't have a filter on them, because that will actually, we had just a little, one of our telescopes got refurbished just a little bit, and we had a loaner scope at the time, and it had a little tiny sighting scope, and the front cap was off of it and the back cap was still on. And actually what happened was that the little scope burned a hole right through it when we were observing the sun one day. Of course, the larger scope did have a filter on it, but the sun is definitely a powerful thing, especially when you're magnifying it, especially into a more direct stream. So you don't want to shine that directly in your eye, because that will be immediate permanent blindness and very severe damage to your eye.
Yeah, the best rule of thumb is if you don't know exactly if you have a telescope and you're really not sure what you need to do to get it set up for solar observing. Just go to, in that moment, try and learn from professionals. Go to a place like Kopernik, see what their setup is like, gain a bit of a knowledge base on it, so that you can do it comfortably. You don't want to be in a place where you're ever questioning whether what you're doing is right, and then going ahead with it anyways.
I did want to note that I am seeing the shadows change, actually. So I have a tree right in front of me. So on the ground, I am definitely starting to see those crescent shapes come in now.
Oh, awesome.
So it's just a little report.
Yeah, that's great. If you are in, I know someone mentioned that they are from Utah and they have clear skies where they are. Jackie here. She says here in Utah, it looks further along than yours in Texas. And I remember earlier she mentioned too that she has clear skies. So if you're anywhere where you got nice conditions out, that's a great thing to look for those shadows.
It's a really neat effect.
So let's see the status of our eclipse here. Oh yeah, so at Kopernik Observatory, even though we can't see anything, our eclipse did just start. About 4 minutes ago, our partial eclipse started in New York. So we have just a very tiny bit of the sun, or the moon crossing in front of the sun right now. And maximum eclipse for us is only 20%, which happens at 1:17 p.m. Your maximum eclipse, this is all, by the way, we realize we're in different time zones. So there's an hour, Sasha's an hour earlier. But I'm reporting this all in for our audience, since we're focused in New York. I'm reporting it in Eastern time. So, and that's what this clock above us is also showing. So the Texas maximum eclipse will be at 12:52 p.m. And around 12:40, we're going to shut our webcams down and just focus on the maximum eclipse event on the big view. So this is the time to certainly interact and chat with us. Also, if you are in a position to support Kopernik Observatory in any way, you could certainly just subscribe to the channel and like this video. We'd love to see you again on any of our live streams from our Friday Night Live programs that cover a range of topics in STEM, not just astronomy, but we go into engineering. This fall we had a computer science talk, and we're gonna have a couple. It is very astronomy focused this fall, but we do have a range of topics there. And then those stream out every Friday night, and you can also visit us for those in person, starting at 8 p.m. on Fridays. And then we'll have some observing streams coming up as well, including the Orionid meteor shower, where hopefully we'll get a nice all-sky view to cover that event. Also, the Orionid meteor shower happens to be the same day, at least the peak happens to be the same day as the as International Observe the Moon Night. So possible we might fit in a little bit of lunar observing as well for that session. Lastly, if you are in a position to support Kopernik through a donation, you can do so either through the chat or there is a PayPal link in the video description. And thank you for your support in any way. Oh, actually, a donation just came in from Nick. Thank you so much. All right. Any questions we missed while I was chatting there? Let's see.
Someone mentioned they're from Fort Worth, which is actually right nearby me. So we're probably getting just about the same view of the sun.
Oh, very cool. Yeah, Christina, I think this is the same person you mentioned, maybe.
Yep.
Yeah, Fort Worth, is saying can't wait till next year's goes right over us. But Texas really lucks out. You want to talk, just chat a little bit about the path?
Oh yeah, anyone in San Antonio, especially, they get both the path of annularity and the path of totality. So Texas gets a crossover of two paths, which is really nice. So they'll get to be able to see, depending where you are, of course, either a really nice partial eclipse or just the full thing for both the annular and the total eclipse. The total eclipse is again happening in April 8th. So they'll be able to observe that.
So neat. Really lucked out. How cool. Well, is it really luck? I guess it's not. Really. It's well predicted ahead of time. But if you don't know about it, I guess it feels lucky.
Yeah, definitely. And you can also look up some of the future eclipses that are happening. That map I pulled up earlier is only for the next about 20 years, and NASA has dozens of those. They go even as far as way into the past and even way far into the future. So you can definitely check out if maybe there will be an eclipse in your area sometime in the future as well.
We did have another question come in. Are full eclipses more frequent in certain areas of the globe?
I wouldn't say so. It's pretty random. Um, Especially again, if you look at the map, it's just most of the time it's over the oceans and it's not a particular place. But you will notice sometimes the path kind of copies and it shifts over. So there will always be two paths that are very similar a couple years apart. Especially when you look at those maps. So it's not frequent in a specific area. It's pretty spread out and pretty random. Um, well, when we look at it, it looks random, but there isn't a particular area that gets more eclipses than others.
Yeah, actually, looking at those maps over the course, we were looking at them before, over the course of 100 years. It is pretty neat to see them all where they'll all be at all at once on one map.
Mm-hmm.
I had a question that's popping in my head here. Will we always have total eclipses?
Ooh, that is a good question. So the moon is slowly drifting away from us. Only a couple, I think it was, do you remember the exact number?
It's only like I think maybe a couple centimeters or something a year.
Yeah, a couple centimeters. But way in the future, the moon will probably be far enough that we'll just get annulars, and then at some point, if it does end up drifting out of, if it reaches escape velocity, it might just completely leave the orbit of the Earth. But yeah, otherwise, I don't believe we will always have total eclipses, especially as that moon does continue to move further and further away from the Earth.
Imagine the ring of fires; they'll get more common as that happens.
Yeah, but that will be over the course of many, many years. It won't be any time in our lifespan, for sure.
Oops.
Oh, Joe says it's 3 centimeters. Thank
3
you,
centimeters.
Joe. Mm-hmm. Ooh, someone asked, I don't know how to pronounce that, but they said, so broad question, what other information do we learn from eclipses that is unique or interesting that you guys know about? One thing that I found quite interesting, NASA's actually doing kind of studies on animal behavior during eclipses. I think there's even people, just civilians can participate. You don't have to be a civilian. You become a civilian scientist essentially. And they're actually asking people to observe crickets, as well as bird behavior. So that's something at least I found really interesting, is kind of how animals change their behavior with the eclipse. And does it have to do with the darkening from the eclipses and things like that. So I found that pretty interesting. It was just that the animal behavior changes, and I can hear some crickets going. So I'm wondering if maybe even I'll notice something happening, especially as we get closer to maximum here.
Yeah, that as you brought that up, I was wondering, like, does it have to be a total eclipse for there to be a noticeable effect on the biology around us? So yeah, that's you'll have to report if any of the birds quiet down, or it's pretty neat. Are you noticing a distinct change in luminosity where you are right now, or?
Not really. It still looks just as sunny as it did. So, but I do see that shadow is getting way more pronounced now. That's the only noticeable difference.
Okay.
Although I guess the temperature isn't getting as warm as you would expect for noon. But that could also just be the weather here.
Oh, that's fascinating too, because of the timing of this eclipse. Yeah, you would expect it to be, you have the hot sun overhead. That's when it's the most direct light, and yeah, this is kind of offsetting that perhaps as it gets more and more covered. Oh, Vincent here is correlating. What is the connection between Texas and space? These eclipses, NASA and Houston, we have a problem. It is funny how it is. Texas, at least, yeah, Houston is a big space hub. So it just happenstance, of course, but it's kind of neat how that worked out with these two eclipses coming up. Oh, I see. You just sent me the picture of those eclipse shadows. Oh, that's pretty cool.
Yeah, that image I found really fascinating, was the shadows changing under the trees. Even on the fence here, I can see that crescent. It's getting really pronounced now.
Wow. I'm really hearing the crickets now for some reason. They I don't know if they got louder there, but they got louder here for some.
Yeah, I think I'm hearing them too.
We had a question that's, do eclipses have any electromagnetic effects on Earth's natural fields? The only thing I can speak to about that is related to the ionosphere, and actually the Ham Radio Club is up here at Kopernik right now, working on a little bit of a citizen science projects on that front. I'm not as informed about that, so I'll kind of leave it there. But it is pretty neat that there is that ham radio citizen science happening. If you know any more too, Sasha, you're welcome to speak to it as well. But
yeah, I don't really have much knowledge on the effects it might have, unfortunately. But that would be definitely something really interesting to research. And that might be
Absolutely.
something they're looking at right now, especially. I might try to adjust our view here a little bit.
Okay. Yep. Perfect. Yeah, I wonder if that. I think it will. That sunspot there. Do you think it's going to be obscured?
It might be. I think it obscured the slightly smaller one that was next to it. Let's see. Guess we'll find out.
Yeah, I'm curious. It's like could be right on the edge.
Yeah. Christina from Fort Worth mentioned it's getting a little bit more gloomy. It still feels kind of sunny here, so I'll see how it gets. It's kind of hard. Ooh, I have a dog behind me.
Not happy about the eclipse.
I think.
Or happy.
Something. Yeah. Yeah. It almost feels. Because otherwise it looks like day, but somehow the sun feels a little different, and it's hard to explain.
Yeah, I remember when the eclipse, when I went to watch the eclipse in June, as the sun was rising, it was already well underway, and it was a very odd sunrise, which makes some sense that effect would be more dramatic because you also have the looking through the thicker part of the atmosphere as you look to the horizon, or you're looking through more atmosphere at least. So that was interesting, the most interesting sunrise I've seen, I think, because of that strange effect of luminosity during the eclipse.
Yeah, for sure. And I'm again, that temperature difference is quite interesting. I'm being hit with direct sunlight, but I don't feel like how you usually would feel the sun warming, even
cool.
with the breeze. But I just wouldn't. I'm not feeling that right now, and that's typically something I would expect from being in direct sunlight.
Yeah, that's a great data point. I'm trying to think if I can't remember what the timeline was for the 2017 eclipse. Let me go back and see if it was what part of the sky it was in at that time, because that got pretty. That was a pretty large partial eclipse too. 2017.
So actually, my cousin just handed me, they made a little pinhole right here.
Oh.
And it works quite well. You really do get that crescent there. But also right now it is 60 degrees, as I've been told. So.
Oh, it's okay.
And then
Was it
around 2, it should go up to 67 degrees.
all right? So maybe there is an effect there.
Mm-hmm.
That's
Yeah,
cool.
it seems like the temperature will start going up as it moves from maximum. At 12, it's supposed to be 62, and then at 1, it goes up to 65, which is quite a difference there.
Yeah, that's significant. So I think I posted this earlier in the chat too, but I'm going to post it one more time so that you have it. It was actually the same link that you shared, Sasha, about the safe solar eclipse viewing.
Mm-hmm.
This one in particular is with those glasses that you can find from reputable sources.
Mm-hmm.
And you can just click that link in the chat to find those. Of course, they won't do you as much good. You won't unless there's like 1 hour shipping or something. You probably won't be able to get them super easily right now. I will say we are as part of admission at Kopernik today. You do get to go home with solar eclipse glasses.
Mm-hmm.
So that's certainly an option if you're local. But otherwise, you can go to this link and get them for your the total eclipse coming up.
Yeah, definitely try to get your eclipse glasses early for that total eclipse, because they're going to be sold out everywhere probably that week before. And again, it's not a good idea to buy them off of a random site online. Someone asked, at what time are we expecting the full eclipse? So in my current location, we'll get partial eclipse, but maximum will be at 11:52 my time here in Texas, which is 12:52 in Vestal or New York.
All right, so we have about 10 minutes until we are going to strictly focus on the eclipse view for maximum eclipse. So if you do have any questions about this eclipse, the next one, feel free to post those in the chat and we'll cover those in the next 10 minutes. We might be back afterwards too, maybe half an hour after maximum eclipse. But so there might be another round of potential Q&A, but just be safe maybe right now. For those viewers on the live stream right now, you may want to put your questions in. We have this one that says, what fields of astronomy do you both usually do? So, I mean, at Kopernik, we do cover as much as we can event-wise. We're a public observatory. We're not involved in much research at all. The 20-inch telescope is definitely a research grade scope. But yeah, we mostly use it for image data capture. So, but like with events like this, we try to cover them both virtually and on site. And we touch on everything: lunar eclipses, solar eclipses, the planets, galaxies. We have a nice dark sky site where we're located. We're about 10 minutes out from the nearest town. And while our northern skies are somewhat light polluted, our southern skies are excellent because you're looking into rural Pennsylvania. So we get really nice views of the Milky Way during the summer, for example. So it's a great resource for our community here, and we're happy we are also able to expand upon that as well with an event like this, observing the solar eclipse from a completely separate state, separate location. So yeah, we cover a wide range of topics. As far as what I'm most interested in, if I could kind of tweak the question a little, I don't know. I guess I do like maybe night sky observing a bit better. It's different though, because like with an event like this is very exciting. It's nice to observe, especially when we can capture detail on the sun and capture the moon crossing its path. But I haven't dabbled too much into heliophysics and solar observing myself. I would like to. There was a previous stream where we did dig into H alpha filters for our 6-inch telescope, and maybe that's something we could return to at some point. But you will find a lot of our streams do focus on night sky observing. Our observing streams are branded, I guess, Night Sky Live. So that's where I like to put the focus on, and I do like planetary observing a lot. We've done a number of streams on both just giving you a live feed of the planet, but also running through some quick processing on with image stacking, so you can collect really strong detail on Saturn and Jupiter. We did so for Mars as well, and you could definitely look out in the future for those streams again. Do you have a particular favorite, Sasha?
Yeah, I mostly just do visual observing, but in my astronomy class, I kind of got introduced to imaging as well, and I really do enjoy imaging, especially nebulas and star forming regions. That's
Yeah, the my favorite to perhaps image on that front is the Orion Nebula, which we'll be having coming around soon again at a nice convenient hour. So it'll be nice to have that in the winter time.
Yeah, it seems like the dogs are slightly changing their behavior here too.
Interesting. Have they been around the whole time, or?
No, they're getting kind of let in and out, but
Okay.
This was kind of the first time I know they reacted to something, but this one was just a little. Although I think they may have wanted to be let inside, but they were really excited to hang out outside, and it seems they don't want to be out here anymore. So maybe they are getting a little scared by that. And it does look like that sunspot's going to get covered.
Yeah, I think you're right. It's getting really close, and we've still got. When is your max? I forgot already.
52.
52. Oh yeah, it'll definitely obscure. Anna is asking, isn't there supposed to be a comet going by the same time as the eclipse? Not at least from what I recall, it's not this one. It's the 2024 eclipse. What's the name of that comet? Comet eclipse. And of course, with comets, take everything with a grain of salt. It's going to be hyped up a lot because it just so happens to be a comet passing by the sun during this eclipse event. Whether or not you'll properly be able to observe it is certainly in question. But I got to remember the comet's name here. 2024. Ponsbrooks. 12P Ponsbrooks specifically. So that's something that's going to be closely monitored for sure. My guess is with the right gear, you probably will be able to, during totality, I'd imagine you would be able to capture that comet through a camera. Whether your eye will see it, that's probably the biggest question.
Mm-hmm.
But it will be neat to see any images that do come out of that. The process images of the comet and that eclipse. Now, this article says it's called the Star Wars comet. Oh, that's right, because early on when it was captured, it looked like the Millennium Falcon when they first started imaging it. I just came across this article that says Star Wars comet. It does kind of look like the Millennium Falcon.
It is definitely getting noticeably colder over here.
Oh, wow.
Mm-hmm.
Someone's asking, did the New York eclipse pass already? I couldn't see. It's too cloudy. No, it started at 12:04 p.m. for us here in New York, and maximum, I believe, is at 1:17. Yep. 1:17 p.m. is our maximum, and actually both eclipses wrap up around the same time. 2:31 p.m. here and 2:29 p.m. both Eastern time in Texas. So our eclipse goes as long as this one. It's just we wouldn't see as much covered. It's only like 20% or so, and then of course we won't see anything at all because there's nothing to see. Too many clouds. Oh, there goes my alarm. So it is 12:40 at this point. Thank you all for joining us during our Q&A session here. Like I said, we might be back after we get through our maximum eclipse stage, but for now we are going to switch over to just a full view of eclipse so that you can enjoy it at home with some nice ambient music in the background. I'll be monitoring the chat during this window so I can interact with you there. And again, I just want to thank everyone for your support. It's a great group this afternoon. And anything you wanted to mention, Sasha, before we head out?
Nope. I think we're all set.
Mm-hmm. All right. Well, we'll maybe see you in a bit, but otherwise enjoy the eclipse, everyone. All right. Hello, everyone. I hope you've been enjoying our coverage of the near annular, at least where we were, solar eclipse in McKinney, Texas. I say we, it's actually where Sasha is above me here. And my name's Jeremy Carty. I'm one of the Kopernik's science educators and the quote unquote live stream astronomer. Um, but that title also goes to Sasha Zalesski today, as she is in McKinney, Texas now, covering the near annular solar eclipse where she is. I'll have her speak a little bit about her experience in just a couple minutes. Before we do, I want to mention Kopernik Observatory is a observatory and science center located in Vestal, New York. We have 3 large telescopes, the 6-inch refractor, 14-inch reflector, and 20-inch reflector, that are open to the public every Friday night. This time of year, we open at 8 p.m. For a Friday night presentation. That is, you can also watch on YouTube right here on our channel, or come up in person if you live locally or near the area. We cover a range of topics in STEM, with some emphasis on astronomy. And then afterwards, you go outside if the skies are clear and look through our telescopes. There's lots to see this time of year, including a couple of planets like Jupiter and Saturn. So we'd love to have you visit sometime. But today our focus is on this solar eclipse that we've been watching. And what I'm going to do now is I will introduce Sasha here, who again is a science educator here at Kopernik. She's part of the Kopernik Astronomical Society, and she is also a NASA solar eclipse ambassador. So if you want to kind of summarize the event, what we've seen, what you experienced on your end, pass it off to you.
All right. Well, hello, everyone. This was actually my first time experiencing a solar eclipse. So very exciting. You start to notice things like the shifts in shadows, which I mentioned as we were going towards the maximum here, since we did get a partial. And even the temperature drop, you feel the temperature change. You notice animal behavior. We discussed that a little bit as well. It started to change as well. If people had dogs, I know we had 2 dogs here. They looked a little bit scared, and the crickets stopped chirping and the birds went silent. So it was quite cold. And even towards maximum, it didn't exactly get dark as how it would for nighttime, like when you're approaching sunset. It was as though it was daytime and someone took a dimmer switch and turned it down. It was just like a shade darker, as well, paired with that colder temperature. And then everything began to warm up again. Those shadows went back to normal, instead of having the little, especially when you look at leaves, they tend to give a pretty cool shadow there where you can actually see the shape of the eclipse. And now it's almost completely back to normal. So it was really interesting to be able to watch and experience that, and just all the effects that happen, not only with the sun, but with the nature around me.
Very neat. Yeah, you used you sent me a couple pictures over the course of the eclipse event, and use a variety of objects to project that shadow, that image of the eclipse. Could you name some of those and some of the fun you had with that?
We were experimenting with a lot of things. If it had holes in it, it worked. So our first one was just a cardboard with a hole punched through it, and then we tried a cheese grater. They had a little game called Mastermind, which has little holes in it, and that one looked really, really cool. Even a cap, like a little hat, they have those little holes on there. That worked as well. And even the roof here, there was a little piece of the gutter that had a hole, and it projected the image, which was really neat. So yeah, a lot of fun objects that you could just use. There was even it was like this thing that just it was like these little balls that just stuck together, and even that worked. And as you turned it, and if you raised it up higher, then the projection would be bigger. But when you brought it down lower, you got these little tiny ones, and there was a bunch of them. So it was really cool. And we did try the technique with using your hands too, and that worked quite well.
That's fantastic. Yeah, it's great to know that even though this can be a you don't want to observe this event directly, it can damage your eyes. There are so many other accessible ways to enjoy it, and that's a big one. So yeah, at this stage, well, first, thank you, Sasha, for sharing those thoughts. It's great to have you there, and for you to have made this all work is just incredible. Because for those that are just tuning in, at Kopernik in Vestal, our original goal was to kind of have a side-by-side look at the eclipse from different perspectives, so that you could see at the same time what does the eclipse look like in New York versus there in Texas. But yeah, we got way clouded out here. It was just, it's been raining all day, overcast, terrible conditions. It's almost like we have exact opposite forecasts here between Texas and New York. So yeah, we weren't able to capture any of the eclipse event here in locally at Kopernik, but we thank Sasha for sharing what she's seeing in Texas right now. So at this point, we're going to keep going until 2:30 when the this partial eclipse wraps up. So we are available once again for any questions that you might have. We'd love to hear from you in the chat. I do want to point out in our eclipse view now, you can once again see the sunspot that was obscured earlier by the moon that recently reemerged. And there actually is another tiny one somewhere around there too that may fade in and out, but pretty neat that we got to see this all play out. So yeah, if you have questions, feel free to post those in the chat. We're happy to answer them live for you.
There we go. I got it back.
Oh. Yep, it looks all good.
So
good on our end. Oh, the other sunspot you mean?
Yep.
Oh, there it is. Yeah, that looks good.
Mm-hmm.
I wonder if the other tiny there's another little one towards about, like, I think I said 5. Oh no, maybe it's more like 4. Oh, I do see it. Yeah, around 4 o'clock. You see that a little higher up? There's another little darker spot. Right, closer to the edge than the other ones, but
oh yeah.
I feel like there's, unless my eyes are just playing with me, there's a little bit of contrast there about where it should be. It's much tinier than the other ones. So we have a question here. Is an SCT or a Schmidt-Cassegrain telescope best for solar observing? I can't, again, we kind of had a similar question earlier about what scope is best, but I kind of steer away from the reflectors in general. Not that they're, like, we have used reflectors for solar projection, like some of our Dobsonians or Astroscans, but I've always been happy with the results from our refractors at Kopernik. Both the 6-inch for direct observation with a filter, emphasis on that. Don't look through a telescope at the sun without a filter, and make sure you know exactly what you need to make that work. And then we do use a refractor for solar projection with our heliostat, and that is an excellent telescope where you can get almost 9-foot diameter sun on our large classroom wall in the other room. It's pretty neat. Also, I do want to mention too, if you are in any way in a position to support Kopernik, there's a few ways that you can. If you enjoyed today's live stream, like the video that shows YouTube that you enjoyed the content. If you want to see more of these live streams, both observing and our Friday night live streams that cover topics in STEM, you can subscribe to the channel, of course. And then there's also you can donate both through the live chat and if you prefer, there's a PayPal link in the video description as well for donations. Oh, and lastly, if you want to get something back with your support from Kopernik, we do have an online shop with t-shirts, sweatshirts, window stickers, all sorts of stuff in there. In fact, on this video, you should see those embedded, so you could just click on one of them and it would bring you right to the shop. So I think specifically, let's see, this eclipse for our area, if we could see it, it'd be wrapping up at 2:31 p.m. Eastern time.
Mm-hmm.
And then for the Texas eclipse, it should be wrapping at 2:29 p.m. Eastern time or 1:29 Central time. So that's where we're headed towards. You can see there's we're seeing less and less of that silhouette of the moon. Oh, here's a question.
Yep.
That's one I don't know if I know how to answer. What is the best way to study sunspots? I guess it depends on what you'd want to study exactly about them. There are actually in our last presentation, the Director of Education, Dr. Susan Higley, had an excellent graphic showing you all the satellites involved in studying the Earth-Sun system. And there's objects like the Parker Solar Probe that are actually get really close to the sun, as close as you can. And it kind of just skims it, because if you stay too long in the region it gets close to, it won't survive. So it has to just quickly zip in, get data, and zip out. So yeah, there's a lot of scientific instruments that are out there studying it. And I guess, again, it kind of depends on what you'd want to study from it. There's a lot of things you could look up there. So we're located in Vestal, New York, which is upstate. It's in the southern tier of New York. Closest city, I guess it would be Binghamton, and then yeah, we're about an hour and a half or so south of Syracuse, almost due south. Marina asks, can you tell us how the donations help the observatory? So in part, our donations through our YouTube channel are to help support the efforts of creating the content for the channel. But also some of it gets funneled into our overall funds at Kopernik. So that's going to support our classes that we have for K through 12 students. It's going to support our Friday night programs. It will support our staff and our mission of science outreach and educating and lifelong learning. So that's really where your support goes. We are a nonprofit organization, so a lot of our funding comes through kind donations like we are getting today. So we thank you so much for your support.
We do have, I'm not sure if I'm interpreting this question correctly, but the solar eclipse is happening over mostly the west coast of the United States and kind of going into the Mexico area. So that's for the annular eclipse that's happening, well, happened today. But the upcoming total solar eclipse in April will actually be more over the East Coast. So kind of from New York going into Texas on occurring. And someone mentioned that they saw something fly in front of the sun. There are some birds around and some insects as well. So it possibly could have been something like that.
Yeah, I was just looking back in the footage to see if I could find what they may have seen, but I'm not having much luck. But yeah, I saw birds fly in front of the view earlier, so that's totally possible.
I'm going to take a quick moment to adjust our view here.
Oh, thank you.
Okay, get it. Uh-oh.
So we have a little less than 15 minutes before this partial eclipse ends and we wrap up the stream. So do keep that in mind. If you have any questions, we're happy to answer those over the next little over 10 minutes or so. Cheryl asks, are we looking at the view from New York or Texas? And this is from Texas. Our view in New York is completely obscured by clouds, and it's been that way all day, unfortunately. As we mentioned earlier, our goal was to kind of have a side-by-side view, so you could really notice how much of a difference it makes depending on where you are, where you're located for eclipse events like these. But we're, the other side of that is that we had two options, and at least we lucked out on one of them. So the weather is as you can see in Sasha's view, it's very nice in Texas right now.
Yeah, very clear. I'm definitely not used to having this amount of clear skies. Is it still raining over there in New York as well?
Last I can open the door again. Let's see what's going on. Yep, still raining.
Oh.
And both eclipses actually wrap up around the same time. The eclipse in Texas did start first, but they do both wrap up around 2:30. I say both eclipses. It's really the same eclipse, right?
That is true, yes. Would be interesting to get a view of a hybrid eclipse at the same time, because then it might be considered both eclipses.
Yeah, that's true. Yeah, we have some kind comments in the chat. So we thank you for your support. We were so happy to be able to make this work for you today, and we couldn't do it without you. So we're happy to have you here. Here's a question for you, perhaps, Sasha. Do eclipses vary in time, or are they always the same length of time?
It definitely would vary, especially depending on your location. We mentioned it beforehand too. Even the duration of certain parts of the eclipse are different. So if, for example, we were closer to the path of annularity, we would have been able to experience annularity. And if we were just slightly outside of that path, it would be a shorter amount of time. So depending on your location, the eclipse will definitely pass faster. For example, the further away you are from either the path of totality or annularity, as well as the duration of actually totality or annularity, depending if you are in that path and how far you are from the center line of it as well. So those definitely do vary. Someone asked, why is the shape of the shadows different as the eclipse passes the peak versus the shadows leading up to the peak? So it would all depend. I would assume you're talking about the shadows that you can actually see in the projection of them. Um, but that would kind of vary as what shape the eclipse is at the time. So the closer we got to the peak, it would become more of a crescent-like shape, as opposed to, say, how it is right now. Then the shape would be similar to that. Actually, right now the shadows are almost back to how they were, but a little bit earlier I could just see the moon in there as well. So it would just depend on what the shape is at the time, if that made sense.
Mm-hmm.
Oh, and Joe adds it also depends on the distance or angular size of the sun and moon.
Mm-hmm.
That might be for the previous question, I think, actually.
Let's also just jump off this discussion on shadows too. What's interesting about the moon shadow is that it's not, of course, a pure circle, right? It's not. In fact, because the moon is a much smaller object compared to the Earth, it's much rougher. So if you could really push the magnification on a solar eclipse look at the edge of the moon, you would notice how irregular that it really is. So it is projecting an irregular shadow on the surface, kind of a complex polygon because of the mountainous regions across the moon.
Mm-hmm.
But of course, we don't see that as such. On average, it's going to look circular in nature.
Mm-hmm. And actually, that same effect, talking about the kind of edge of the moon, is you get those Bailey's beads if you get a perfect annular or a total eclipse. So that's kind of the light shining around the imperfections there on the surface.
Yeah, like kind of like the I've heard it referred to as like the diamond ring effect, right? Where you get that bright
too.
peaking in brightness. Yeah, that's cool.
Mm-hmm.
We're getting really close now. Just about 5 minutes before the partial eclipse ends, and then that will lead us on to the next eclipse in 2024, which will, I think, be even more exciting with totality. question about the moon specifically. Why is the visible side of the lunar surface so different from the dark side? Yeah, this is I guess first thing, of course, this is kind of semantics. Like the dark side of the moon, there is no dark side of the moon. There's the side that faces us, and there's the side that faces away from us because it's tidally locked. But the side that we don't see still receives the same amount of sunlight compared to the side we do. But either way, it's kind of semantics. As far as your main question goes, that's still kind of a debated subject from what I understand. They're not exactly sure why. I've seen some theories that it could be in part due to the way meteors impact the moon. So one side is more of it. There's more remnants from its formation with those seas or the mare, versus the other side that is more heavily impacted. May have something to do with the era of heavy bombardment. I think it's still in debate why it is the way that it is, but it is pretty neat to see that contrast between the two. They are drastically different. Oh, look at, yeah, this is really just a tiny little sliver now, a little bite out of the sun.
Yeah, almost completely. Do you see that little sunspot? I haven't been able to spot it yet.
I do see that there's like a little bit of contrast, like a little. It's a little darker about 4 o'clock on the sun, right towards the edge, but it definitely looks like a speck of something.
Okay.
They're almost right in a line, in fact. Like you can almost connect them. I'm not sure if I'm seeing much evidence at all of partially eclipsing now.
Yeah, I think it's already passed.
I think you're right. Which is about, it was around 2:29, I think, that they said. So, yep, there it is. So, yeah, that's about it. Now, technically, there is a tiny bite out of the sun for us here in New York, but again, we can't see. So, that about wraps up the stream. Thank you again, all of you, for tuning in. It was a great time chatting with you and enjoying this astronomical event. And I want to thank Sasha again as well for making this happen and giving us, anyone that has cloudy skies like those of us in New York, the chance to enjoy it. Yeah, look out for future streams that we have coming up. Next Friday is going to be on International Observe the Moon Night. Technically, it's a day early, but we're going to prep you for it the following day and talk to you about what that NASA-led event is about and a little bit of what's happening with the moon in terms of space exploration. And then the day after, we have the Orionid meteor shower. If it's clear, Kopernik will be open for observing that meteor shower and looking through our telescopes too. And we will also have a live stream going as well to capture any meteors that fly overhead. Stay tuned for other content as well. There's lots to explore up here at Kopernik. And if you are in a position to support us, like Cheryl just has, thank you so much, Cheryl, for your donation. If you are in a position to support us, you can donate right through the chat here, through the PayPal link in the video description, or just subscribe and like this video. We'd love to see you again on future live streams. All right, so we're going to shut things down now. Thank you again, both to Sasha and to the chat here, and we will see you next time. Look up and dream big, everyone.